Thank you, everybody. I'm very happy to be here among you today in Turkey. I'm Mahmoud. I'm a research scientist. I work in solar cells and photovoltaics. Usually, I develop a new type of solar cells, very, very advanced type of solar cells that you might see in the market in the next few years. And today, I will take you in a brief round to discover the marvelous world of nanotechnology. So, first question is, what is a meter? How do we define a meter? A standard distance from a point to another point. So, what is a centimeter? The same, but smaller, right? Okay, so how do you define a nanometer? Exactly, smaller. How much smaller? 10 to the power of minus 9, which is 1 part of a billion part of a meter. This is really, really small. So if you want to imagine how small is 1 nanometer, you can think about it like a tennis ball. This is 100 million nanometers. So what is nanotechnology? I think you have heard a lot about that, right? Everywhere. This is nanoscience, nanotechnology, nanomaterials. You talk about wow stuff. So nanotechnology is everything that we can make in the scale from 1 to 100 nanometer, or in some cases in a few hundred nanometers. So if you are making like a processor, computer processor, with some logic gates and transistors that are like 10 nanometers, 50 nanometers, this is nanotechnology. This is a cross-section of a solar cell under the electronic microscope. And usually it's colored just to distinguish the different layers of it. It's around 1,000 nanometers thick, very, very thin. This is a hydrophobic surface. This is a water-repellent surface. It's nanostructured and nano-treated to repel the droplets of water. You see these small parts, these are in the nanoscale. So this is also nanotechnology. This is a gear and a chain. The size of this one is 100 nanometer. This is called micro electromechanical systems and nano electromechanical systems, and these are complete machines that are built under the nanoscale. You cannot see it with your eyes. You can see it only with the electronic microscope. Very, very high magnification power. So all of this in nanotechnology, but why nanotechnology is important? Why some people consider it the next big change in the world? Why it is going to change our life? This is the question. In fact, the properties of nanomaterials is different from the normal materials that we see. For example, gold. What is the color of gold? Yellow, right? Shiny yellow. So what is the color of gold under the microscope? The nanoparticles of gold. It's green. So if you look at gold under the microscope of the nanoparticles of gold, it looks green, not yellow anymore. So when you go smaller, the properties of the material, the same material, in fact, it changes. And this is the point. So if the properties of the material can change, so we can use it for different applications if we can manipulate it and control it in the nano scale. So let me show you a very, very important early application of nanoscience. And some people consider it the first seed of nanotechnology. It was the ability of some scientists to hold and move a single atom. They could literally hold a single atom like this and can move it from a place and put it into another place, one atom. And they can even photograph it. They can take a photo of an atom. And those are two scientists, Billinger and Ruher. One of them, I think, is British. This guy and this guy is German. And they did it in 1981 at the IBM labs in Switzerland. And they got the Nobel Prize for that in 1986 for this work. How did they do it? They made a new microscope called the scanning tunneling microscope. It's not so important to see it because it's a complicated machine. But anyway, it's a needle, very, very small needle. It ends up with a single atom, and then through an electric field. They can hold one atom, only one, and they can move it. And then they can stack these atoms next to each other. And they did it, and using some 10 atoms, they wrote IBM on a chip and took a photo of it. Here it is, in 1981, very early. 45 years ago, 43 years ago. And they got Nobel Prize for this. This is a single atom. This was the very first picture of something that people see and see. What you see right now is an atom. No one have ever seen it before that. And that's why they deserve the Nobel Prize. And this was the beginning of nanotechnology and nanoscience. Afterwards, we can move atoms. So the question is, can we move molecules? Can we assemble molecules to each other? The question is yes. If we can move an atom, we can move a molecule. How? Let's see. Yeah. What is this? Molecules. These are molecules. Yeah, but what you see? What is this? Looks like, not very clear. Okay, so these are tires, 4 tires. So what is this? A car, exactly. That's a nano car. Composed of some polymer molecules in the middle. This is the chassis. And there's some cyclic molecules that you study in organic chemistry. These are cyclic organic molecules that form the wheels. And this is, yes, that's a car. And it can move. And that's it. This is a new nanotechnology science. It's called molecular machines. So you can make machines using molecules that you can see under the microscope. And this can open up a new venue for engineering very, very small machines and robots that can do very, very amazing functions that I will tell you later. But even this deserves the Nobel Prize. These 3 scientists got the Nobel Prize. One of them is Ben Feringa, this guy. I met him in person. He's very, very funny. You can look for his name on YouTube. He has many, many nice lectures that will be very easy for you to understand. He's called Ben Feringa. He's from Netherlands. And they got Nobel Prize for that, but the invention was not only making a car, but you can assemble molecules and make fascinating stuff. And then people followed up in this direction, and they have developed the concept of making micro machines and molecular machines under the microscope, and they even did a nano car race, a race for nano cars, and it worked. You can see how these molecules work. These are the microscopes. And this is just a teaser of the competition. You can see the full version on YouTube. I cannot show everything here because it takes like 10 minutes. So they can design different molecular structures for making them move. And then 6 teams were in a competition. 2 of them succeeded to pass the finish line. So it was a wonderful. So you can see how engineers and scientists think about making these molecules. Yeah, but I know, or even I'm sure that you are thinking, yeah, what is the benefit of making a car under the microscope, right? Why? So even this concept have developed, not only making a car, but you can make a motor, a rotating motor. And this rotating motor is made using some proteins, polymers here, and some lipids to make this flying wheel, and it works. This is a graphical illustration because it's very difficult to shoot a video under the scanning microscope, but it works. They made it. And this is used to kill some of the bacteria outside a cell. This is the wall of a cell, and this is some bacteria, and this is used to kill it. This is just conceptual design. So what is the benefit of making these motors and making these fascinating machines? Looks a lot of science, a lot of work, but what's the benefit? For example, we can make a small robot. These 3 protein molecules, these are designed in a molecular machine and can go inside your body and repair a damage in the DNA strain. And even in the future, you can also inject your body with some buckyballs of fluorine molecules, which are nanomolecules, and go into a certain defective body cells, and then they repair it. You can imagine in the future that also you take a capsule with many robots inside. Of course, this is a concept. This is not true yet. And I hope you don't need it. So with many robots inside the capsule, and then it goes inside your body and fixes damage. Yeah, but the nanotechnology is not only in medicine or in materials, but also in renewable energy. So how could the nanotechnology resemble the next shift in renewable energy? This is a silicon wafer, which is a solar cell that you see on the roofs everywhere. It looks black, or in most cases, it's blue. But then if you see it under the microscope, this is a solar cell under the microscope, you see how thick is it? From 70 to 200 micrometers, and this one, you can see is around 30, 40 micrometers. Very thick material. But then with the nanoengineering and nanoscience, we can make much thinner solar cell. So we can make like this. How thick is this? This is 1 micrometer. This scale is 1 micrometer. So how thick is the solar cell? 1 micrometer or even less. Some other types, which is the perovskite solar cell. This image is from my lab. You see how thick is it? 0.5 micrometer. This is 500 nanometers, which is half micrometer. So you can notice that the amount of material to make 1 square meter of this solar cell is enough to make 400 square meter of this solar cell. So you can think how cheap is it? How easy to make is it? But why thickness is important other than materials and price? It's transparency. We can make transparent solar cells, and by modifying the surface, we can make it colorful. So we can make the green, brown, blue, whatever the color is it. And why this would be important? You can put it in a car roof. So you can still your car roof, and it still generate electricity that would be used inside the car, or even used for charging the batteries or helping the car to get longer range. And this is testing in Japan. You see the engineer here is testing the output of the solar panel on the roof. Also integrated solar cells in buildings. These colors are not colored windows. These are solar cells. It still can absorb a portion of the sunlight and generate electricity, while the other portion of the sunlight enters the building and you still have the light inside, and also a very beautiful scene from the outside. So you can think about integrating solar cells in your balcony doors or in your windows or whatever. You still have the window and you still can generate electricity. Wearable electronics. Electronics that you can wear in your backpack, in your side bag. Rollable solar cells. These solar cells can be rolled. You can see this image, I got it from AliExpress. This is a product you can buy right now in the market. It's very cheap, like I think $25. Very cheap. You can get a solar cell that you can put in your backpack, you can put it anywhere, and you can even buy different products. But how do we make these solar cells? It's made by nano-engineering, and engineering a very, very thin layers that could absorb light still, and could be put on bendable substrates and so on. These solar cells are printed. It's not made industrially, it's printed like paper, because it's very thin. And it can make very, very fast. So you can make hundreds of square meters per minute. Now, let's jump into another field, which are batteries. Batteries is very important. This material called graphite. Graphite is the carbon material that you can see, for example, in the pencil tip. It's a very cheap material. But if you can take one sheet of graphite, only one sheet, one atom thick, you get a graphene. And the graphene has completely different properties than graphite. Graphene is very light. It's very, very strong. It's 100 times stronger than steel. Very, very strong material. And of course, it's a perfect thermal conductor and electrical conductor as well. That's a processor. This is the iPhone 9 processor. It's a bit old, okay? And what you see here, what are these? Are these repeated units? This one? That's a transistor that you can see under the microscope. If you cut your computer processor and put it under the microscope, you will see this. You will see a city of logic gates and the transistors stacked together. If you can put more transistors in a smaller size, you see here, it goes smaller, 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 and smaller, until you cannot see it even under the microscope. This is for the iPhone 14 Pro, if you have it. 16 billion transistors. It can make over 20 trillion processes in 1 second. This is how it's made. Inside, this is a vacuum machine in which they use array of mirrors and lasers to engrave the processor here. So your processor is made here under this one by a pioneering company called ASML. They are the only company in the world that make these machines. That's during the assembly of the production line of the processors. It's made inside these fascinating machines. There is no room of time to talk about it. So finally, I hope you get an overview about the wonders of the nanotechnology and nanoscience. Thank you.